In this video, we'll go over the answer key for Monday, March 30th. So what we're first dealing with are polyprotic acids. Polyprotic acids are acids that have more than one hydrogen on them. Now, each hydrogen can be acidic, that is, each hydrogen can come off the molecule. And each hydrogen has its own Ka, its own acid dissociation constant. However, the second hydrogen, for the most part, is the Ka is so small that for most polyprotic acids, we just ignore its contribution and treat polyprotic acids like a monoacid or a binary acid. But it really depends on what you're using or what polyprotic acid you're looking at. So let's look at 0.5 molar H3PO4, and I want to know what the concentration of H3PO4, H2PO4, HPO4, PO4, and H3O plus are, and the pH. So this problem is a long one in that you have to do an ice table 3 times because each form of the acid is like a weak acid. So let's begin. We have 0.5 molar H3PO4. So H3PO4 plus water will go to H2PO4 minus plus H3O plus. From the chart on the previous page, the Ka for this is 7.5 times 10 to the minus 3 equals products over reactants. I set up my ice table. I have 0.5. Water's a liquid, so I don't care. 0 for H2PO4 and 0 for H3O plus. So no products, only reactants. So minus x plus x plus x. 0.5 minus x, and x. Now, if you look at our Ka, it's 0.0075. That is not 100 times smaller than our starting concentration of acid. So I cannot say this x is negligible. So my expression is 7.5 times 10 to the minus 3 equals x times x divided by 0.5 minus x. Multiply each side by 0.5 minus x, move x squared to the other side of the equation, and we have a setup for the quadratic equation. 0.00375 minus 7.5 times 10 to the minus 3x minus x squared is 0. Use the quadratic equation, solve for x. X is 0.0576. Therefore, this acid, H3PO4, the concentration is 0.4424. Our H3O plus concentration is 0.0576. pH equals minus log H concentration. So our pH is 1.24. All right. So let's move to H2PO4 because this is polyprotic acid, so this H2PO4 can act like an acid as well. H2PO4 plus H2O goes to HPO4 2 minus plus H3O plus. So from the previous problem, we saw that we start with 0.0576 H2PO4. And we start with 0.0576 H3O plus as well. That's what we solved for. We have no HPO4 2 minus though. However, we have one product that's 0, so we're going to lose reactants, so minus x, and plus x. At equilibrium, we have 0.0576 minus x, then 0.0576 plus x. If we look at our Ka is 6.2 times 10 to the minus 8. So the minus x here for H2PO4 and the plus x are negligible. Basically, this H2PO4 loses so few hydrogens that it actually doesn't change the amount of acid we got from our first step. So we set up our Ka, 6.2 times 10 to the minus 8 equals 0.576. That's our acid concentration, multiplied by x, divided by our H2PO4 concentration, which is 0.0576. We have 0.0576 at the top, 0.0576 at the bottom. These two numbers will make 1. So X is simply 6.2 times 10 to the minus 8. That's the amount of HPO4 we have. Okay, now we have some HPO4, and that can break down to become PO43 minus in acid. So from the previous problem, we saw we have 6.2 times 10 to the minus 8. I have X here. This should be 0. We don't know how much PO43 minus we have. And we have 0.0576 H3O plus. So we have no product for PO43 minus. So this is minus X plus X plus X. So at equilibrium, the HPO42 minus is 6.2 times 10 to the minus 8 minus X, X, and 0.0576 plus X. However, Ka for HPO4 is, again, super tiny, 4.2 times 10 to the minus 13th. So the minus X and plus X are negligible. And we set up our Ka expression. Again, it's products over reactants. H3O plus multiplied by PO43 minus divided by H2PO42 minus. Fill in our E's. So 4.2 times 10 to the minus 13 equals 0.0576x divided by 6.2 times 10 to the minus 8. Multiply each side by 6.2 times 10 to the minus 8, and you get 2.6 times 10 to the minus 20 equals 0.0576x. Solve for x. X is 4.52 times 10 to the minus 19. So finally, that gives us all the parts we need to answer this question. The concentration of H3PO4 is 0.442. The concentration of H2PO4 minus is 0.0576. The concentration of HPO42 minus is 6.2 times 10 to the minus 8. Concentration of PO43 minus 4.52 times 10 to the minus 19th. Our H3O plus concentration actually never changed when we first solved it, so it's 0.0576, and the pH is 1.24. So this is why I said on the previous slide, when we're dealing with polyprotic acids, we generally don't care about the other hydrogens that come off past the first one. The Ka constants for the other hydrogens are so tiny they are negligible, and when we're calculating pH, we only really care about the first hydrogen that is lost, as shown here. All right, so the last two problems are just looking at trends, so there's nothing complicated here. So on a binary acid, as you move from left to right on the periodic table, your acid becomes more acidic. As you become, or as you go further down on the periodic table, it becomes more acidic. And acidic just means how likely are you to lose your hydrogen. So HF versus HCl. HCl is further down, so more acidic. H2O versus HF. HF is further to the right, more acidic. H2SC versus H2S. SE is further down, so more acidic. And the last problem looks at the strength of oxyacids. Oxyacids have multiple oxygens associated with them, and there's 3 rules for oxyacid. One, as you move down a group, the acidity it becomes more less acidic. Rather, the acidity will decrease down a group. The acidity will increase as you move right, and the more oxygens, the stronger it is. So our first rule here is actually the opposite of binary acids, but our second one is right along with it. So if we look at H2SO4 versus H2SO3, SO4 has more oxygen, so it's more acidic. HClO2 versus HClO, O2 has more oxygen, so it's more acidic. HCl versus HBrO, so I actually have this backwards. So it should be HClO because ClO is further up the group. And CCl3 versus our CH3. So CCl3 is further to the right, and so it would be more acidic. So further to the right does matter more than it matters more than up or down on the periodic table. And that's all for these questions. If you did not understand anything, you're still confused, please do not hesitate to email me and I'll be happy to work it out with you. Otherwise, I'll see you in the next video.